In this episode, we're going to talk about how you can customize your HTTP/JSON API. So we're going to talk about Smithy and HTTP and JSON specifically. And for that, I'm going to use the simple REST JSON protocol. So when I say customizations, what I really meant is what kind of traits we can apply, HTTP or JSON specific traits that will make our API behave as we want. For example, we're gonna pick up where we left off in episode 4. We're gonna use our weather service. We had the simple REST JSON protocol from Alloy, so just REST and JSON. And we barely had any traits. We have required, we have HTTP because we needed that. We have read only because we needed that on a get operation. Then we have HTTP label, which is arguably the most interesting one here. And that's pretty much it. So what other traits can we use and what would they be useful for? First of all, where can we apply traits? Right now we only have a trait, an HTTP trait on the operation, of course, the protocol, that's arguably HTTP, and we also have HTTP label in the input. We can apply traits essentially anywhere that a specific trait is allowed on. For example, HTTP label has a selector that says it can be applied on a structure, on a required member, and it has to be one of these types: string, number, boolean, or timestamp. Selector syntax is, personally, I think it's pretty difficult to read when you're new to it. So it definitely takes some getting used to. You can read the docs and I promise you will not be feeling much better about this, but I think it comes with experience and kind of just seeing these things as you work with Smithy. Well, hopefully you won't need to read selector syntax too much and you'll get some better high-level validations, but every now and then you may have to understand a selector or two. For example, in required, we can just target a structure member. So this is probably the more trivial one. So that's something to consider. And as you can see, HTTP label doesn't say that it has to be an output, but there's a validator running for HTTP label which has to check that this member appears in the path, and the path of an endpoint is only a thing in the input. So it's kind of a given that it has to be input. If we try to put this into an output, we'll get an issue because, first of all, it's not a required one. Let's see. Now it's just ignored here. So yeah, it's just telling that it has to be in an input. It's not a great error message, to be honest, a great warning, but it kind of does the job, right? So that's HTTP label. There are other traits, and in order to find out which traits are supported by your protocol that you're using, you can actually go to the protocol, and this should be a pretty good source of truth for that. This may not be sufficient source of truth, let's say just that, because some traits may be specific to the code generation tool that you use. For example, Smithy 4S has its own traits that are only for code generation, and it doesn't really matter if the protocol supports them or not, because they influence the output of your generated code and not necessarily the behavior at runtime, okay? So to find out the runtime traits or the protocol traits, we can go to the protocol definition, and it actually has to list all the traits that it supposedly handles. So here we can find HTTP, of course. We have default, which is a trait used for default members. From the previous video, you may remember defaults as something like this. So that's kind of syntactic sugar, but what it actually does under the hood is say default ASF, something like this. That's equivalent, okay? Same goes for documentation, by the way. If you do triple quotes, something like this, it's equivalent documentation with AASTFG. So the more you know. So again, we have HTTP, HTTP error. We're gonna talk about errors in a whole separate video. We have HTTP header, HTTP label, so the URI parts, HTTP payload. This is gonna be about bodies. We'll talk about that in this video. HTTP prefix headers, that's not a super common one. HTTP query, HTTP response code, and then there's jsonName for JSON, a couple constraint traits, timestamp format. We also talked about this in the previous video, and some Alloy specific ones, for example, for different union encodings, such as discriminated and untagged, which I don't recommend. Again, I said this in the previous video. So back here, let's see what happens if I add some new parameters. Let's say we have like a region, that's going to be an HTTP header. And for a header, you have to specify the name. So let's say X region. Actually, I'm not sure if this is a good convention to use, this X prefix. I saw some arguments that say it's not great, so I'm just going to say WS for weather service, which again, this may again conflict with something else. Let's say SWS, like Smithy weather service. And now it's an optional parameter. Let me make it required. And now we have required parameter. And if you don't send this header, this SWS region, for example, with HTTP, this would be SWS region hello. Now that would be sent as this header. If you don't do that, you'll get a rejection, a bad request error. So that's what HTTP header does, of course, and you can replace it with HTTP query region, and that's the same thing. You would have to do region equals hello. So you can actually switch these things quite easily once you compile your code. Like actually, let me do this. Let me try to run my app, and this will fail because I'm missing some things. Let's comment this out. Let's just focus on the server side. Now my code doesn't compile because I'm not supporting this parameter. So this is kind of the workflow that you have. You change your spec and then you have to update your code accordingly. But as you'll notice, your code does not have to deal with HTTP detail. We also talked about that in previous videos, I think. So now I have this region parameter. It's a required string. And I didn't say it's a header, right? So let's run that. And actually, let me print that region. I'm going to run the app again. And I think it's a header at this point, is it? No, it's a query. So I'll send that. Yeah, of course. I really like this. Like when you want to send an HTTP request with a question mark, you have to escape it with a backslash or wrap the whole thing. I really don't like it. So as you can see, this is being sent as a query parameter again. And it's being seen by the server because it's just seen, right? That's what I sent. I sent hello, hello 2. You can see that. Now, if I change this to a header and I recompile my code, this will no longer work. That's all I had to do, just change the spec. I didn't touch the code. So I also got a 404. I had very precise info. It didn't find the field region in this header. So instead of a query parameter, I'll go back to sending a header, and now it's going to be foobar, and you can see that it actually works. So that's kind of the true power of Smithy, and that's what HTTP header and HTTP query look like. They also have their own limitations. You can see that in the selector, and there's also validators. And as you can see, they're exclusive to each other. You cannot have a parameter that's both a header and a query. That's what the conflicts thing does. So now we have a header. We talked about query. We will get to bodies in a second, but first I want to show you that you can also apply traits on outputs. For example, this degrees thing, that's a field in the response. And at the moment, it's by default goes to the body. I can mark it as a header and rerun, and it will be a header. There it is. So numbers are allowed here. I can move this to the other parameter, the other response parameter, and now the situation is flipped, right? We just changed what is a header. Of course, region doesn't make sense here, but you get the idea, right? So that's HTTP header. We also have HTTP response code. So this is kind of a magical thing. I'm not sure, it will probably not work because the number is too low, but basically what this allows you to do is dynamically determine what the response code should be. So by default, it's just 200 when you have an HTTP operation. You can specify a different one here. We did that in the previous video. So now my get would be a 201. Doesn't make sense because this is created, but still. It will be a 201 always. Now, what if I want a different status code, even in a successful situation, right? Then that is exactly when you use HTTP response code. When this member is present and it goes into the 200 to 400 area, I think, then that's going to be used here in the response. Let me see if I can easily make that happen. Let's say 201. I'll recompile. Yeah, and let me change the number here. That's gonna be a 280, let's say. I don't think that's a real code, but who knows? And now I get 280, right? If it was a 404, I think it would be ignored and we would just get 201 because of what's in the spec. So yeah, this is still limiting and you cannot do like everything you want to do with it, but it gives you some power, some control to kind of go out of the declarative nature of Smithy and into more dynamic determination of the values. Now, sorry, I have to stop my dog from doing stuff. Okay, my dog was doing some stuff, so I figured I would show you what she looks like. So yeah, that's Hauka. Hauka, get the camera. She's the prettiest dog of all time, but she's so crazy. Anyway, let's just hope that doesn't happen again. So the next trait I want to cover is jsonName. And that's, I think, only or like mostly useful in structures and unions. It basically allows you to say like, even though in the Smithy model, this is called degrees, in the JSON, I want it to be called like temperature. Because like degrees is like an implementation detail to me. And guess what? My code does not have to change. The parameter, even if I did use named parameters, it would still be degrees because the jsonName thing only affects the runtime, not the compile time stuff. Basically runtime behavior and what the interpreter of my service is going to do. That is what the traits like jsonName control. So when I get my response, yeah, I think it doesn't work with HTTP response code. They should actually have a check for that. I'm not sure why they don't. It's probably just oversight. But yeah, you can see that it's called temperature now in my response. That's jsonName, and if this was a union, it would have the same effect. I don't think it works for anything else. Yeah, it's just structures and unions. For example, it wouldn't work for enums because in enums you already have like a name thing. In this case, a jsonName thing, which is the value. So when you have an enum like city ID, of course, sure. This is your jsonName, right? So you don't have the jsonName trait here because this replaces it essentially. So that's it. And finally, we can get to httpPayload. Now, you have seen this already. We're gonna use the output for an example. Everything goes into the payload by default. And it's only when I add some other traits like HTTP label or HTTP header or HTTP query that these things disappear from the body and they go somewhere else. So if I say this is now a header, you'll see that instead of 2 fields, I have just 1. Why does that happen? Well, that's just the Smithy HTTP behavior. So by default, the entire structure, the entire input-output is the body. You can only remove things from it and move them somewhere else. So then your output is kind of split between the body part and the non-body parts. And here, this is the non-body part, this is the body part. I can have more of these body parts. Oh my God, this sounds so wrong. And now I have 3 fields in the body and 1 header. However, let's say you want your whole body to be something else that already exists. So instead of just adding things to the body, you want to basically replace it. Let's say I want to have a city. If I had the structure city, let's say it has a name that's going to be required, and an identifier that's also going to be required. Let's say I want this to be my output. If I add my city as an output, let's remove this. Now I will have this one level of wrapping. I'll just have a city field in the output, and that's going to have the value of a structure. What if I want to flatten that? Well, that's when you use httpPayload. So let me give you an example actually, because I think this may be difficult to understand without an example, a practical example. So we have degrees is gone now. We'll have a city, and that's optional. And we're gonna have London, and ID is going to be city ID from the parameters. That does not work because I need an import from the hello package, which corresponds to the hello namespace. And that should work. So this is like the wrong case. This is what I don't want. I have a city parameter, a city field, and a structure inside it. Now I can use httpPayload and rerun my code. And there it is. It's just flat. I can also say string, by the way. If I were to do that, I'll have a top-level string body, which is something we cannot do like normally. Like you cannot very easily do that without httpPayload, or you cannot do that at all, because you cannot say output is string, because output has to be a structure. The only way to have like top-level JSON string or top-level JSON non-object is to use httpPayload. So if I run that again, I'm not sure if I'm on the latest state, we have a top-level string. So that's it. Let's go back to the structure. And let's consider some edge cases. I cannot do this, right? I cannot have an httpPayload and some extra fields, because what does Smithy do with this, right? Where does it put the crease? Would it merge it into city? Well, they don't want to make this choice for you, so they don't let you do that. So you can only have one member with httpPayload, or you have none of them. You cannot actually, I think, have two, yeah. There's just like one. And I think that's checked by this structurally exclusive thing, by the way, which is a parameter of the trait. So yeah, this is how you use httpPayload. To sum up, because I know this could be pretty confusing the way I explain it, there are three main kind of code paths that we can go into when httpPayload is or isn't present and other bindings are present or not. We have the default case, no bindings at all. Everything is a body field. By the way, your card is fine. Everything is a body field. So if I rerun, right, we have city and we have weather. That corresponds to my members here. Then we have the second case. We have a mix of body and non-body things. This is a body member. This is a non-body member. Now, only the subset of body members are going to appear in the body, but they are still kind of nested. There's no flattening happening. And then we have the third case, which is the body is whatever httpPayload is on. And now it doesn't really matter if we have other things or not, like other bindings or not. The body is just going to be this one thing. The rest does not influence the body, because if the rest exists, the other things like weather or whatever query parameters, well, not in the response, but in the input, that would be possible, having labels, HTTP queries, and so on. This doesn't matter. This is the only body, the only thing in the body. The body is going to be a city, and these things go to the metadata part of HTTP. I hope that explains it. Three cases that you have to worry about, and usually you get the hang of it pretty quickly, right? Just play with it some more, and you should be able to tell at a glance what this would serialize as. In this case, I can tell that's my body, the city. So just my body is going to have two members, and I'm going to have a header. I want to dive a little bit into how Smithy 4S at runtime is actually able to tell where it should put these things. Like, does this go into a header? Does this come from an HTTP query? And the way it does that, you see all these traits that we have here, they are replicated in the generated code, but not as types, they're replicated as metadata. For example, let's find the getWeatherOutput type, which is a synthetic shape created from this based on a naming convention. Let's find getWeatherOutput and let's see HTTP header. So this is getWeatherOutput, and HTTP header is present here in the hints section of my my thing. So we have this thing called schema. I want to talk about this in detail today, but just to give you kind of a taste of the Smithy for us metaprogramming facilities. We have the schema that contains information about all the fields that we have and how to construct the value from these fields, like the value of the structure, as well as all the schemas of the members and all the hints which represent traits from the Smithy model. As you can guess, the word trait is not a great one for your data types in Scala because it's a keyword. So that's, I suppose, where hints comes from. So yeah, that's kind of a glance of what that looks like under the hood. And as you can imagine, there is an interpreter somewhere that, like looks up the collection of hints on a given schema, and it checks like, does this have a header hint? Does this have a payload hint? And then it constructs some more codec-like things, decoders and encoders of HTTP fields and metadata. So all that happens at runtime, which it does come at runtime costs, especially during application startup, but this is how Smithy4S achieves protocol-agnostic code generation. So that's it. So thank you for watching. I'll see you in the next video.